Today's lecture I will discuss about three power devices like triacs, diacs and unijunction transistor or UJT. Let us discuss about triacs. The SCR has a disadvantage that it cannot conduct current in both directions. The triac, that is often called as triode AC switch, can conduct current in either direction and is sometimes referred to as bidirectional thyristor. Triacs have on and off states for both positive and negative anode voltages and are consequently useful in AC application. The figure shown in figure A shows the basic structure of a triac. Its schematic symbol is depicted in figure B. The device has three terminals, of which M1 and M2 are the main terminals and G is the gate terminal. Basically, triac consists of two SCRs oriented in opposite directions to give bidirectional characteristics. The anode of each SCR is connected to the cathode of the other. When M2 is given positive voltage with respect to M1, we get the conventional behavior of one of the SCRs. When M2 has a negative voltage with respect to M1, the other SCR behaves conventionally. The current voltage characteristics of the triac is therefore symmetrical as shown in figure C. The voltage between the main terminals at which the triac goes from off state to an on state is the firing or the breakover voltage. As in the case of the SCR, the firing voltage of the triac can be controlled by applying a positive or a negative current to the gate terminal. Triacs are used in motor speed control, temperature control, etc. Now, what is diac? This is the schematic diagram of a diac. The diac is referred as diode AC switch. Is a 2-electrode 3-layer bidirectional avalanche diode that can be switched from its off state to its on state for either polarity of the applied voltage. The basic structure of a diac is shown in figure A. It is similar with a PNP bipolar transistor. The difference from the bipolar transistor is that the doping levels at the two junctions, PN junctions and NP junctions, are nearly same, and no other terminal like base terminal is connected. The equal doping level provides the symmetry, and the bidirectional switching characteristics is almost symmetrical, which is shown in figure C, which is shown in figure C. The device symbol that is shown in figure B. If a positive or a negative voltage is applied across the diode terminals, one PN junction is forward biased and other PN junction is reverse biased. Suppose if we apply a positive voltage in the diode terminal, the first PN junction that will be forward biased and the second NP junction that will be reverse biased. The current flowing through the device will be the reverse saturation current, because through the reverse junction the diode the forward biased current cannot be flown. The current flowing through the device is considered as IB0, where IB0 is the reverse saturation current. The leakage current of the reverse bias junction, or the leakage current of the reverse bias junction. When the applied voltage reaches the breakdown voltage, the avalanche breakdown voltage of the reverse bias junction, then the junction breakdown takes place. The current increases rapidly. Forcing the device to show a negative resistance characteristics, which is shown in figure C. Negative resistance characteristics. In this region, the device current increases while the terminal voltage decreases. Diodes are used in triggering the device in triac phase control circuits. They also find application in heat control, motor speed control and light dimming. Now we will discuss the function of a unijunction transistor. Now, what is the unijunction transistor? Now, a unijunction transistor, it is also called a UJT, consists of an N-type silicon bar that is lightly doped, but the doping is uniform along the channel. The silicon bar is provided with ohmic contacts at the two ends. The silicon bar is provided at the ohmic contact at the two ends, and a PN junction near the center of the bar is indicated as shown in the figure A. The device has only one PN junction and a control feature accounting for its name. The N terminals are called base, that is here the B1 and B2 are the base, and the terminal related with the PN junction, that is called emitter. The resistance of the bar between B1 and B2 is generally in the range of 5 to 10 kilo ohm. The figure A and the figure B, figure A shows the schematic diagram and figure B shows the circuit representation. Now let us consider a positive voltage VBB is applied at B2 with respect to B1. The resulting current IB through the bar produces a voltage drop eta VBB between B1 and the point along the bar where the p region is formed. The fraction eta is called the intrinsic standoff ratio. Let RBB, RB1 and RB2 be the resistance of the bar between B1 and B2, between P region and B1, and between P region and B2 respectively. Then we can write that the eta, that is equal to RB1 by RB1 plus RB2, that is equal to RB1 by RBB. This is a formula of potential divider. And the voltage Vp, that is equal to eta into VBB. Now consider a positive voltage V is applied to the emitter E with respect to B1. As long as V is less than Vp, Vp means eta VBB. As long as the V is less than Vp, the PN junction is reverse biased so that a small reverse current flows in the emitter circuit. This is shown by region 1 of the characteristics shown in figure C. Shown in figure C. The region 1 is called the cutoff region. When V exceeds Vp, the PN junction is forward biased and the holes are injected into the bar. These holes are dragged by the electric field produced by VBB towards B1. The conductivity of the portion of the bar between the P region and the B1 is thus enhanced. As a result, a large emitter current IE flows and the voltage between E and B1 decreases rapidly till it attains a value VV, as shown in figure C. A value VV till it attains a value VV corresponding to the current IV. The device thus shows a negative resistance in region 2 in the IV characteristics of the device. When the current becomes larger than IV, the voltage between emitter and the B1 starts to rise. Again, this portion of the characteristics is called the saturation region and is denoted by region 3. When the emitter current is less than IP, the device is in the off state, and when the emitter current is greater than IV, the device is in the on state. The voltage Vp is termed as the firing voltage or the breakover voltage. Thus, similar to a thyristor, a unijunction transistor has high impedance off state in the cutoff region and a low impedance on state in the saturation region. The difference is that the switching in a transistor originates from regenerative transistor action, but in the UJT it arises from conductivity modulation in the negative resistance region